Hi everyone, welcome to this video lesson. And in this video lesson, you're going to learn how to solve absolute value equations when you have variables on both sides of the equation. Okay, so you have three possibilities. One is the absolute value graph and the line intersect each other at 2 points, which means you have two solutions, or the absolute value graph, which again is the V-shaped graph, intersects the line at 1 point, so there's one solution. It's also possible that the absolute value bar, again, which is the blue line or light blue, the V-shaped graph and the red line do not intersect at all, so in that case there is no solution. So we must check these answers so we can, they could be extraneous answers. And extraneous just means that you get a false statement, so it is a solution, but graphically they will not intersect, okay? So with that said, just like on the previous lesson, you want to isolate the absolute value on one side of the equation. I see that there's a 6 in front of it, so I'm going to divide by that 6 on both sides of the equation. So then we have the absolute value of 2x plus 5 is equal to 6x divided by 6 is just x, and 24 divided by 6 is 4. Then the absolute value is isolated. So this is when we set up the two equations. So one equation is 2x plus 5 equals, notice, these two change signs, so equals negative x, and then that 4 becomes minus 4. And the other equation is 2x plus 5 equals, leave that as x plus 4. Okay, so then solve. So for this one here, I'm going to add x to both sides of the equation. So then this becomes 3x plus 5 equals negative 4. Then I'm going to subtract the 5 from both sides of the equation. So then we have that 3x equals negative 9. Then I'm going to divide by negative 3. So then x equals positive, let's see, we're dividing, I'm sorry, this is positive 3, not negative 3. So we're dividing negative 9 by positive 3. So the solution is x equals negative 3. So far we have one solution. The other solution, subtract 5. We can let's start with the x first. Okay, I mean we can do either way, it's fine, but I'm gonna be consistent as I did on the first this equation. I'm gonna do the same thing here. So minus x, so this is x plus 5 equals 4. Then subtract 5 from both sides of the equation. So then x equals 4 minus 5, which is negative 1. So now we have x equals negative 3 or x equals negative 1. So I'm going to check these solutions. Okay, so I'm going to check to see if I get a true statement. So all I have to do is look at the equation, and whatever I see on x, replace that x with a negative 3. So there's a 6 in front of the absolute value. 2 times, instead of x, negative 3. And then at 5, is this equal to 6 times negative 3 plus 24. I'm going to pause the video and write that down. Okay, so this video is not too long. Okay, so then 2 times negative 3 gave us negative 6. But then negative 6 plus 5 is negative 1. Plus 5, and I forgot to write the plus 5 on this one. Okay, so then so this is equal to negative 18 plus 24, that's 6. And I don't know why I made this mistake. Okay, let me erase that real quick. So this is the absolute value of negative 1, which is positive 1. So 6 times 1 is 6. So then we got a true statement. So therefore, this solution works. So that one works. Now let's check this one. Okay, so all I've done is I plugged in for x with a negative 1. So then this is 6 times the absolute value. 2 times negative 1 is negative 2. And then plus 5 inside of the absolute value. 6 times negative 1 is negative 6 plus 24. Then negative 2 plus 5 is 3. The absolute value of 3 is 3, which means we're multiplying 6 times 3. Okay, and 6 times 3, as you know, is 18. So we have a true statement. Therefore, this solution also works. So we will have the line of the equation, which is y equals 6x plus 24. And the V-shaped graph, the absolute value, 6 times the absolute value of 2x plus 5 will intersect at these coordinates for x. Okay, so they will intersect each other at those x values. All right, so let's go on to the next example. Same thing. We need to isolate the absolute value. There is a plus 2. Let's subtract that 2. So then this is the absolute value of x minus 6 is equal to 2x plus 8. Again, this is a line, this is a v-shaped graph, okay? So since the absolute value is isolated, we can remove the absolute value bars and set up the two equations. So again, this will be negative 2x minus 8. That's one equation. The other is x minus 6 equals 2x plus 8. And then we solve. So for this one, I'm adding the two x's. So then we have x plus 2x is 3x minus 6 equals negative 8. Then I'm going to add the 6. So we have 3x equals, that's negative 2. Then I'm going to divide by 3. So x equals negative 2/3 or negative 2 over 3. Okay, that's one solution, which we don't know if it's extraneous. So then let's do the other equation. I'm going to subtract the x from here. So then we have negative 6 equals x plus 8. Then I'm going to subtract the 8. So then this becomes negative 14 equals x, which is the same as x equals negative 14. So solutions are x equals negative 2/3 or x equals negative 14. Then again, I'm going to check the solutions. So all I've done is I'm checking the first solution, x equals negative 2 over 3. So I'm plugging in for x. Instead of x, replace whatever you see on x with negative 2 over 3. Okay, and then this is 2 times negative 2 over 3 because it's 2x. So I'm going to compute this. So what I've done inside of the absolute value, since this has a 3 and this 6 is implied to have 1, you multiply the 6 by 3 so you can get a 3 in the denominator. So you multiply by 3 over 3. So we end up with negative 18 over 3. Okay, so we've done this lesson. This was the beginning of the course when you reviewed how to add, subtract, multiply fractions. All right, so then this becomes absolute value of negative 2 and negative 8 combined to negative 20. So negative 20 over 3 plus 2 is this equal to, and this 10 is implied to be over 1, which means we need to multiply numerator and denominator by 3. So then this is 4 over 3, and this becomes 30 over 3, because we multiply top and bottom by 3 over 3. Okay, so then the absolute value of negative 20 over 3 is positive 20 over 3 plus 2 equals, this is negative 4 plus 30, that's 26 over, over 3, right? Okay, this 2 is implied to have a 1, so then you multiply top and bottom by 3 over 3, so then this becomes 20, this is 20 over 3 plus this becomes 6 over 3. So then 20 plus 6 is 26, and 20, and we have 26 over 3 on this side. So that means this solution checks or works. So this one we checked and we got a true statement. Then let's do the same with the second solution. So again, what I've done is instead of x, see how that's x minus 6, I substituted x with the negative 14. So then, and 2 times x will be negative 2 times negative 14. So the absolute value of negative 20 plus 2 is this equal to 2 times negative 18, that's negative 28 plus 10, and I hope you can see what's going to happen here. Absolute value of negative 20 is positive 20, and negative 28 plus 10 is negative 18, and 20 plus 2 is 22, and 22 is not equal to negative 18, so this is false. Okay, that's a false statement. Therefore, this solution is extraneous or EXT. I'll just write the whole word for this. So this is the only solution that works. The other doesn't work. So that means we have this case. They only intersect at one point. And that's all for this lesson. Thank you for watching. I'll see you in the classroom. Bye-bye.